In this series of videos, I will show you how to build a vacuum chamber to evaporate some metals, and the first step will be to fix this scroll pump. So we should start by testing it, just to see what's wrong. Okay, that's not good. I think it's the starting capacitors. I will open it to check everything, and I'll start by disconnecting the wires and removing the backplate. We can see that it's an axial motor. All the coils are focusing the magnetic field to this metallic disc, and this isn't a permanent magnet, it's just an iron core, which means that it's an induction motor. I don't see any obvious issue with the power supply, so I should try to spin the motor alone without the vacuum stage. Okay, it works, but it takes a long time to start, so there is probably another electrical issue. It's certainly not from the capacitor, so it must come from this component. I studied the datasheet a bit more, and the wiring looks like a centrifugal switch, which was very common for induction motors. The working principle is very well explained by Jeremy Fielding, but in short, when the motor is spinning fast enough, the contacts are splitting, which disconnect the starting capacitor. I looked for an electronic version on AliExpress and found this one for cheap and bought it. I will do a little bit of cleaning while waiting for the delivery. So a scroll pump is a dry pump. There shouldn't be any oil inside. So I will clean everything with ethanol. And I will remove the seal. It's a specific PTFE seal, and it's the only wear piece on this scroll. We can clearly see the two sides of the pump. The rotor oscillates with an eccentricity inside the stator, and it gradually pushes and compresses the gas in the middle of the spiral. I think I lose the same seals. A good cleaning should be enough. The seals are clean, and I did another full ethanol wash of the inside, so there is absolutely no oil left. But unfortunately, the stator is a bit damaged and there is some scratch on the seals. The easiest and cheapest thing to do here is to flip the seals. A new kit will be about 300 euros. So I will just add a bit of vacuum grease to fill up the scratch in the joint. I'll start by the center of the pump and push the steel down the groove all along and cut the excess. I still don't have the new component, but I want to test the vacuum anyway. So I've mounted a basic vacuum gauge and I will power the pump with my trusty drill just to see if I can have a decent vacuum. Okay, it works. Great. So I've just used the masking tape as a seal, which is far from ideal, but the vacuum is okay. I was convinced by the previous test, so I will do it in real conditions. I've just connected the starting capacitor in parallel, so I can power it for more than a few seconds. And it works! Great! And the vacuum is good. Okay, so I'll lay this aside and I will focus on the next project. Bye!